Okay, evolution of atomic theory and counting atoms. This is part 4. We're looking at today calculating the molar mass. The mass in an atom in AMU is also equal to the mass in grams of 1 mole of that element. So if I looked at hydrogen as an example, the AMUs, the atomic mass unit for hydrogen on the periodic table, is 1.01. Remember, we round to the hundredths place. The molar mass is the same thing, but I changed the units. The molar mass is 1.01 grams per 1 mole. Magnesium has 24.31 AMUs, and it has 24.31 grams per 1 mole. Sodium, there's 22.99 AMUs and 22.99 grams per mole. Molar mass is a number of grams per 1 mole. You can also flip that and say 1 mole per number of grams. And we'll need that for tomorrow's lecture when we look at converting between molar mass, grams, and particles. To find the molar mass of 1 mole of any substance, we count the elements present and add them up to their atomic masses. The total mass in AMUs is also equal to the mass in grams of 1 mole, and that's represented again as grams per mole. And it's better, again, guys, to write it over each other. Mole, the only way to abbreviate mole is MOL. So let's take a look at an example. This is an example of calculating molar mass. Our first example, we're going to use water. Water is H2O. You know that you have 2 atoms of hydrogen, and each one of those hydrogen atoms has an atomic mass unit of 1.01. And then we have 1 oxygen atom, and its atomic mass unit is 16.00. Well, in order to find the molar mass, I have to take into account all of the atoms in the compound. So I have 2 at 1.01, which is going to equal 2.02, and then 1 atom at 16.00. If I add those together, I get 18.02, and that is known as the molar mass of water. So 18.02 grams over 1 mole. And you don't need to put that 1 there, it's understood. Let's take a look at another example, calculating the molar mass, this time of sodium chloride. Well, we have 1 atom of sodium, 1 atom of chlorine. The atom of sodium has an atomic mass unit of 22.99, and then chlorine has an atomic mass of 35.45. If you add those 2 together, we're going to get 58.44 grams per mole. That's the molar mass for sodium. Let's look at carbon dioxide. There's 1 atom of carbon, and that has an atomic mass unit of 12.01. And then we have 2 atoms of oxygen. Sorry, that's an O. 2 atoms of oxygen at 16.00. So that's 12.01 for the carbon, and then 32 from the oxygen, and when we add that together we get 44.01. So the molar mass for carbon dioxide is 44.01 grams per mole. Again, you're looking at the periodic table to obtain the AMUs for each element. If you have more than a particular element, then you have to take into account all of them. So we just multiply it. 2 times 16, or you can add 16 twice. Let's look at another example. This one is calcium phosphate. Calcium phosphate is Ca3PO4 2. For the calcium, I have 3 atoms of calcium, and each atom of calcium is contributing 40.08 AMUs. For phosphorus, the phosphorus and oxygen are both inside the parentheses, and then I have a subscript outside the parentheses. So I have to distribute this 2 to everything, just like you do in math. There isn't a subscript on the piece on the phosphorus, so that just means 2 times 1 is 2. So there's 2 atoms of phosphorus, and that's contributing at 30.97 AMUs. Again, these numbers are coming from the periodic table. And then for oxygen, there's 4 atoms of oxygen inside the parentheses and then 2 outside. So I multiply. 4 times 2 is 8. So I have 8 atoms of oxygen at 16.00. When I multiply this, first for my calcium 3 times the 40.08, that's going to give me 120.24. And then for phosphorus, that's 2 times the 30.97. That gives me 61.94. And then oxygen, 8 times 16, that's going to give me 128. You add all of these together. When you add them all up together, you should get 310.18 grams per mole. Again, finding the molar mass, you take the AMUs, which is the same as the grams per mole for each atom, and add it together. For calcium, there happens to be 3 atoms of calcium, so I had to include all 3 times the amount from the periodic table. My phosphate, this PO4, is inside parentheses, so I have to distribute the 2. So I have 2 phosphorus at 30.97. And then 2 times 4 is 8, so 8 oxygens at 16. Add again all of those together, you get 310.18 grams per mole. Okay, I have one for you. You're going to do iron 2 nitrate. If you guys would go ahead and calculate the molar mass, the answer for that, 179.87 grams per mole. You can check yourself. Please make sure that you are getting that, and if not, bring your questions to class.